Okay, we will start our class now. I will share the slide for chapter 9. This is a very easy chapter. Chapter ni you dah belajar dalam fizik. A very easy chapter. We call that metrology. What is that metrology? Metrology is actually is something related to measurement or precision. Okay. In correct term, in correct term, metrology is engineering metrology is defined as the measurement of dimensions such as length, thickness, diameter, taper angle. It means taper, angle, flatness, how flat the surface it is, and profile, how the profile it is. Either ada peak or valley and others. Okay, there are two types of inspection approach in metrology. First is post-process inspection. It means the measurement has been made after the part has been produced. This is the traditional approach. Macam contoh yang tadi lah, macam bila kita produce a part using a 3D printer, some of the part need to have a post-processing. Especially for the surface finish lah. It means that we need to abrade the surface and the surface in order to get the smooth, the smaller surface roughness. Okay, and then the second approach is the in process ataupun online or real time inspection. Measurement are being made while the part is being produced on the machine. This is the current approach lah. Which means during the process, during the machining, we can inspect the part punya dimension online, directly, okay, ataupun in situ. Maksudnya tak ada, sebelum dah siap part baru kita measure. But then in situation sekarang ni, biasanya kita during the machining we can inspect the parts. It means that how much the length, how much the angle, semua tu kita boleh buat inspection secara kita panggil real time inspection ataupun online inspection. Okay. Okay, an important aspect of metrology in manufacturing process is the dimensional tolerance. This is the permissible variation in the dimensions of a part. Yang ni, the tolerance actually you have already learned in engineering drawing and CAD. Contohnya lah, kan? So that kita perlu ada tolerance. If let's say you want to drill a hole. If let's say this one lah, the hole we want to drill, ni screw lah kan. If let's say this is the hole, you want to drill a hole with a diameter of 21. Actually, we do not need to drill the exactly 21 millimeter the hole. But then we need to have a tolerance, plus minus, maybe plus minus 0.1, 0.2. Because apa kata, in assembly process nanti, maksudnya the whole tu kita boleh assemble lah dengan something, contoh macam something apa kata, something apa kita panggil yalah, ada whole. If let's say kita ada satu part yang kita nak masukkan dalam tu, at least dia boleh masuk lah part tu. That is the important tolerance. Okay. Yalah, saya cakap tadi, the tolerance are important because of their impact on the proper functioning of the product, part interchangeability and manufacturing cost. Maksudnya kalau katalah tak ada tolerance, mungkin kalau kita masukkan apa kata, ada satu benda tu dia akan ketat lah. Ketat maksudnya nanti susah lah nak keluar. Susah kita nak tukar-tukar. Okay. Contoh paling mudah adalah you punya USB tadi tu kan. USB, flash USB masuk dalam you punya komputer punya USB punya port tu. Kalau tak ada tolerance, mungkin boleh masuk tapi tak ada keluar. That's why kena ada tolerance. Okay. The width, depth, angle and other dimension All must be produced and measured accurately for the machine tool to function as expected. Okay. Okay, this is the measurement standard. There are two terms that commonly you are used to describe the type and quality of an instrument. The first term is resolution. Resolution, ni semua tahulah resolution. Kita ada high resolution or lower resolution. Biasanya kita guna dalam pictures kan, dalam photos. Resolution is the smallest difference in dimension that the measuring instrument can detect or distinguish. Kalau smallest difference in dimension, maksudnya resolution lah. Maksudnya kalau kata ada satu petak macam ni. Kalau katalah ada satu petak macam ni. Okay, kalau kata dia macam ni okey lah. Okay, ada satu lagi macam ni. Sama, tak Kemudian ni dia punya petak ni lebih kecil. Lebih kecil. Ni petak dia lebih kecil. Dia punya kotak-kotak tu lebih kecil. Jadi ni maksudnya ini lebih resolution dia lebih tinggi daripada yang ni. Okay. That is mean the smallest difference. Okay. Precision pula sometimes incorrectly called accuracy. When precision is not the accuracy. Accuracy, precision is precision. Is the degree to which the instrument gives repeated measurement of the same standard. Okay. In metrology, the words instrument and gauge often are used interchangeability. Gauge is a device used to make measurement. Gauge is an instrument. Gauge adalah instrument. Okay. Dia macam apa kata, instrument dengan gauge tu dia benda yang sama. Okay, sebenarnya. Okay. Temperature control is very important, particularly for making measurement with precision instrument. Okay. Okay, this is the measurement standard lah. Okay, dalam engineering kita ada length, diameter, roundness, depth, flatness, parallelism, perpendicularity, angles, and also profile. Okay, and then this is the some of the measurement tools. Yang ni saya rasa awak semua tahu lah kot. This is the micrometer. Ni of course lah, kalau tak tahu saya nak cakap apa lah. Kan, ruler. And then this is the vernier caliper. Sekarang ni kita dah ada vernier caliper yang jenis digital. Dia dekat sini lah nombornya. And then this is the bevel angle protector. Ni jaranglah kita guna. Okay. Okay, sekarang saya nak tunjuk you satu video berkenaan dengan precision tadi. Precision dan juga accuracy. What is the difference between the precision and also the accuracy. Okay. So saya akan ni satu video. Kita music mode. Okay. Kenapa dia tak ada ni? Share your computer audio. Oh, ada dah lain lah. Share your computer audio. Kalau tak dengar cakap saya pun tak pasti dia dengar. Okay.
Hi viewers, in this video we are going to discuss about accuracy and precision. Gives the same value. In this video we are going to discuss about accuracy and precision. This accuracy and precision are both terms associated with the measuring process. Accuracy is the agreement of the result with the true value of measured quantity. From this accuracy, we can know how the value is deviate from the true value. Precision, repeatability of measuring process. How far the different kind of measuring process gives the same value, that is precision. The distinction between accuracy and precision will become more clear from the following example. Suppose in a graph I am taking the frequency in x-axis.
Jangan, saya pun tak pasti lah.
Ada, boleh dengar.
Tak, dia tadi ada suara tak? Ada kan? Sebab saya memang tak dengar. Ada Okay, okay. Sekejap, saya share balik.
Hi viewers, in this video we are going to discuss about accuracy and precision. This accuracy and precision are both terms associated with the measuring process. Accuracy is the agreement of the result with the true value of measured quantity. From this accuracy we can know how the value is deviate from the true value. Precision, repeatability of measuring process. How far the different kind of measuring process gives the same value, that is precision. The distinction between accuracy and precision will become more clear from the following example. Suppose in a graph I am taking the frequency in x-axis and dimension in y-axis. I am going to manufacture a component of shaft with a diameter of 25 mm. And this value I am going to measure by the different measuring process. The first value is 25.48 mm, the second value is 25.51 mm, and third one is 25.52, and fourth one is 25.54. The four measuring process, different kind of measuring process give the different kind of reading, but the values are very close to each other. Suppose the different kind of measuring process give the repeatance here. So these are average value is 25.5 mm. Now the values here very close to each other, so the repeatance given by the different measuring process. So here the four measuring process are precise. The average value is more deviate from the true value. The average value here 25.5 mm, the true value is 25 mm. So here is more error. Error is nothing but difference between the true value and average value. Here the error is 0.5 mm. So the value is, average value is more deviate from the true value. So we can say here this measurement process are very precise but not accurate. We can say here it is very precise because the repeatance are same. Approximately all the values are very close to each other, but not accurate because the average value is more deviate from the true value. If we have another example, same parameters taken x and y axis, the true value is 25 mm. Suppose the first measurement gives the value of 23.8 and second measurement 25.1, third one is 25.4, fourth one is 26.5. Now the average value is 25.20. The error here 0.2 mm, but the values are repeatance are not here because the first value is 23.8 and fourth value is 26.50. Now we can say here accurate but not precise because the error is reduced here, so the average value is going to be near to the true value. The error is reduced, so we can say here accurate but not precise because the four measuring process doesn't give the very close value. First value is 23.8 and final value is 26.5. The four measuring process gives the different kind of reading, so it is not precise. From these two examples, we can clearly understand which one is precise, which one is accurate. Here we can say four values are very close to each other. So these four measuring process gives the very close value, the repeatance, that is precise. And here the error is reduced. The true value and average value is very close to each other, that is accurate. Then we see another example here. the same parameters in x and y axis, the first measurements and second, third and fourth measurement, different kind of measuring process here taken here, that average value and true value are coincide with each other. Also the repeatance are same here. All the values are very close to each other, and average and true value also merging with one another. Now we can say this measuring process and measuring instrument more accurate and more precise. Accuracy we can find by using this formula, square root of the repeatability square plus systematic error square. Error is nothing but the difference between true value and actual value. Thanks for watching.
Okay, sambung. So nampak the difference between the accuracy dan juga precision. So that, precision tu kalau kata ada satu line tu, and then kita buat beberapa eksperimen. Kalau kata beberapa eksperimen, kalau 5 eksperimen, kalau kata nilai dia adalah contoh kata ni ada satu line, kita buat, katalah line ni nilai dia 10. And then kita buat eksperimen. Katalah eksperimen pertama nilai kat sini, eksperimen kedua kat sini, eksperimen ketiga kat sini, keempat kat sini, kelima kat sini, keenam kat sini. Kita buat sampai 10 eksperimen. So that all this apa kata this plot ni kalau katalah menghampiri this line, maksudnya dia adalah persis. Okay. Itu beza ada accuracy dan juga precision. Okay. Okay, this is the measurement tool. Gauge, apa panggil dia? Gauge. Gauge ni dia ada berbagai-bagai jenis. Yang di sini kita tuliskan kita ada 5 types of gauge. Yang pertama adalah gauge block. Okay. Gauge block are individually square. This is the gauge block. Rectangular or round blocks of various sizes. This is semua adalah gauge blocks. For general use, they are made from heat-treated and press-release oil steel. Okay. Lepas tu kita ada satu lagi adalah fixed gauge. This gauge are replica of the shape of the parts to measure. Although fixed gauge are easy to use and inexpensive, they only indicate whether a part is too small or too large when compared to an established standard. Okay, and then kita ada plug gauge. Commonly I use for holes. Ring gauge I use to measure shaft and similar parts, and then snap gauge. Commonly I use to measure the external dimension. Okay, sebenarnya untuk gauge ni adalah sebenarnya lebih kepada untuk kita ukur the standard part. Let's say contoh ni lah, dia kata cari untuk fixed gauge. Untuk fixed gauge ni, kalau kata kita masukkan dalam satu lubang, kita nak tengok sama ada lubang tu kecil atau besar je. Menggunakan this fixed gauge. Kalau kata gauge block ni, yang ni, let's say kita masukkan dalam satu lubang, let's say katalah lubang tu 100 mm kan. Jadi kalau kita masukkan dalam gauge tu dalam 100 mm lubang, maksudnya betul lah apa kata lubang tu adalah 100 mm. Jadi measurement tools iaitu gauge ni sebenarnya dia lebih kepada untuk indikator saja. Indikator the standard punya size. Okay, this is the type of gauge lah. A and B example of plug gauge. This is not go, and then this is go and then not go, and then kita ada mana tadi? C. C adalah ring gauge, and D adalah snap gauge. Jadi saya tunjukkan video. Okey, dia ada dua jenis lah. Go dan juga no go. Yang tadi lah go dan juga no go. Apa maksud dia? Okey, untuk go, contoh ini adalah lubang. Ni you punya gauge tadi lah. You punya gauge go dan no go. Ni let's say this is the gauge yang go ni. And then this is yang no go. No go ni. Okay. That maksud dia limit of the two sides, which corresponds to maximum material limit considered. Okay. Go gauge is the minimum limit of the hole. Go gauge is the maximum limit of the shaft. Okay. Contohnya ni, kalau kata kita nak ni adalah minimum limit of the hole kalau kita gunakan go. And then go gauge juga dia adalah maximum limit of the shaft. Okay, ni adalah contoh, ni adalah maximum limit of the shaft. Ni kalau hole, yang ni kalau kita apa kata kita bayangkan shaft. And then no go pula, no go if the two sides which correspond to minimum material limit consideration. Okay, no go gauge is the maximum limit of the hole. And then no go gauge is also the minimum limit of the shaft. Okay, nampak tak? So that kita ada dua, satu kita no go, satu lagi kita ada go. Okay, kalau go ni adalah minimum limit of the hole, minimum limit of the hole apalah, this one minimum limit of the hole. Kalau kata no go gauge ni adalah minimum limit of the shaft. Okay. Okay, this is the A gauge. A gauge also called pneumatic gauge. Okay, used to measure the main bearing dimension on a crankshaft, and a conical head for an A gauge, not smaller air holes on the conical surfaces. Okay, this is the gauge lah, the conical gauge. Okay, and then this is the modern tools. Modern tools kita menggunakan laser, laser gauge. Kita menggunakan elektronik, laser micrometer, laser interferometry dan juga coordinate measuring machine. Some is better feature, better resolution and accuracy, automatic error compensation, indirect measurement, electronic and sensors. Okay. Okay, kita tengok dulu apa itu gauge tadi. Okay, kita tengok plug gauge pula.
Hello everyone, welcome to Gauge Hub, and today we'll be talking about plug gauge. Here we have the go side and the no go side. Where the go side it is 0.0 mm and for the no go side it is 0.270 mm. Whereas the basic size is 25 head 7, and here the head 7 stands for tolerance. And now let's see what is a plug gauge. Plug gauge is used for assessment of hole or diameter of an object with specified tolerance of go and no-go side. Plug gauge is also known as pin gauge. Behalf of checking the diameter, plug gauge is also used in comparing, setting, calibrating of other gauges. Plug gauges are available in variety of tolerance of metric or British standard. The easy way of finding go or the no-go side. Go side of plug gauge is always less in diameter but larger in length. But in the case of no-go side, the diameter of the no-go is always greater than the go side. As shown in figure, let's say plug gauge is 25 H7 where H7 stand for tolerance, standard plus zero point 0 or plus 0.27. So go side is 25 mm and the no-go side is 25.270 mm. Here is the workspace or the bore. Simple measurement by plug gauge. Just axis by which side of gauge is fit in bore. And this is all about plug gauge. Thank you for watching this video. Do like, share and subscribe to Gauge How and follow us on Facebook and Twitter. And give us your feedback in the comments down. Hello everyone, welcome to Gauge How, and today we'll be talking about simple measurement by snap gauge. Here we have the snap gauge where the go measurement is 25.55 mm and the no go measurement is 25.45 mm. Here the go measurement is slightly higher than the no go measurement. Snap gauge is go and no go type gauge. That means snap gauge consists of two fixed measured distance or gap. One is known as go and the other one is known as no go. Go means your job or workpiece is okay and no go means your workpiece is rejected. In snap gauge, value of go is always greater than no go. So let's see an example. We have a snap gauge of size 12.500 plus or minus 0.050 mm. So our go size is equal to 12.550 and the no-go size is 12.450 mm. It is measuring criteria for a workpiece. According to this snap gauge, 25.55 mm size is acceptable for a workpiece. When we push a snap gauge towards the workpiece, the only area of go covered, that is, the workpiece is accurate. If snap gauge is able to move till the no-go area, that means the workpiece is undersized. Snap gauge is usually checked for outer surface, which can easily be observed favorable or not. Thank you for watching this video and do like, share and subscribe and follow us on Facebook and Twitter and give us your feedback in the comments down below. And for more, visit our website gaugehow.com.
Okay, itu tadi gauge contoh-contoh gauge. So kita sambung. So this is the measurement, the modern tools of the gauge. Okay. Okay, this is the pointer on the measurement. Okay. Source of the variation in the production, kita ada 4 iaitu static and make deflection of the machine because of vibration and fluctuating forces are caused by machine characteristics and variation in the properties and dimension of the incoming material. Okay. And then the second, the distortion of the machine because of thermal effect caused by such changes as in temperature of the environment. Okay, and then of metal working tools and of machine bearing and various components. Okay, ini adalah source of variation in production yang mengubahkan you punya dimension. Disebabkan oleh static and dynamic deflection, disebabkan oleh vibration, and then disebabkan oleh distortion of the machine, disebabkan oleh thermal effects dia akan mengubahkan you punya dimension, and then of course, the weight of tool, dies and mold can also affect the dimensional accuracy, and then the human error lah, and also the miscalculation. Okay. Selection of an appropriate measurement instrument, particular application also depends on the size and type of parts to be measured, the environment, temperature, humidity, dust, and so on, operator skill required, and also the cost of the equipment. Okay, this is the geometric dimension and tolerance. Dimensional tolerance, this is defined as the permissible or acceptable variation in the dimension, height, width, depth, diameters, and also the angles. And then tolerance unavoidable, and because it is virtually impossible and unnecessary to manufacture to parts that have precisely same dimension. Okay, this why kita perlu adakan tolerance. Kalau katalah hole dengan apa tadi, shaft, dimension dia sama, memang takkan boleh assemble, memang takkan boleh muat. That's why kita perlu ada tolerance. Furthermore, because close dimensional tolerance can increase the product cost significantly, a narrow tolerance range is undesirable economically. Okay. This is apa kata the graph of the if let's say this is the material of the steel, this is the cost, and so apa kata dah adalah graph dia. Okay, kalau kita tengok, kalau kita pergi kepada 100, kita akan dapatlah dia punya tolerance dia berapa, and then what is the finishing operation. Okay, then ni sama jugalah, ni this is the approximate relative cost of progressive tighter dimensional tolerance. Kalau kata rough mean lebih kurang 0.030, dia punya relative cost dia adalah dalam 100. Kalau kata standard machine, dia punya relative cost dia adalah 200. Okay, maksudnya lagi yang ni surface finish lah, maksudnya lagi apa kata, lagi yang ni dia punya surface finish, dia punya surface roughness, maksudnya lagi apa kata, lagi smooth, lagi mahal. Okay. Okay, this is the geometric dimension and tolerance, important tolerance control. Dimension and tolerance become important only when a part is to be assembled made with another part. This is the important of the tolerance bila kita nak buat assembly. Surface that are free and not function do not need close tolerance control. Okay, this is the tolerance lah. Kalau macam ni maksud dia 0.753 adalah yang paling maksimum, 0.754 adalah yang paling minimum jarak ni. Yang you boleh buat. Sebab lukisan, kalau kita sebagai engineer design engineer, kalau you buat lukisan ni kena ada tolerance, sebab you kena bagi pada orang production, production untuk dia buat you punya parts lah. Kalau tak ada lukisan, kalau tak ada tolerance, dia tak boleh nak buat, nanti tak boleh masuk you punya part. Okay, this is the geometry. This is the illustration showing the basic size, deviation, and tolerance on the shaft according to the ISO system lah. Kalau kata ni adalah hole, ni adalah shaft, yang ni adalah minimum diameter of shaft, ini adalah maximum diameter of the shaft. Jadi yang ni adalah apa kata, itu antara minimum dan juga maksimum kita panggil lower deviation. Okay, and then antara minimum diameter dengan zero line ni, zero line of deviation, kita panggil dia tolerance. Okay, and then antara maximum dan juga zero line ni kita panggil upper deviation. Okay, this is the basic size lah. Sama jugalah dengan hole punya apa kata, dia punya terminologi dia. Okay, kalau hole dia macam contoh untuk tolerance antara maksimum dengan minimum diameter kita panggil dia tolerance. Untuk lower deviation pula dia ada antara minimum diameter dan juga basic size. Dan upper deviation pula adalah antara basic size dan juga maximum diameter. Okay, basic size ataupun apa kata dia punya line itu adalah kita panggil line, zero line. Okay, this figure above show the various methods of assigning tolerance on the shaft. Yang first adalah ni cara-cara menulis tolerance. Yang cara yang pertama adalah bilateral tolerance. Ini adalah dia punya basic size 40 tambah 105, ni adalah maximum tolerance, dan juga ni adalah minimum tolerance, negatif 0.05. Maksudnya you punya dia punya saiz shaft ni boleh 40.05 ataupun 39.95. Okey. Ini adalah unilateral tolerance. Dan yang ni adalah limit dimension. Maksudnya dia teruslah 40.05, dia terus je maksimum, nilai maksimum ke nilai minimum. Okey. Yang ni diambil, ini adalah diambil yang apa kata ni, diambil yang tengah-tengah lah 40.05. Maksudnya yang ni diambil yang terus maksimum unilateral ni, sama ada dia ambil terus maksimum ataupun minimum. Kalau yang ni diambil nilai terus maksimum, which means the maximum tolerance adalah 0 lah, and then the minimum adalah negative 1.1. But then the value is still the same. The maximum is 40.05 and then the minimum is 39.95. Okay. Ni the dimension of hole are more difficult to control than those of shaft. The hole system commonly is used for specifying tolerance in shaft and hole assembly. Okay. Ni untuk hole and shaft basis lah. Okay. And then ni apa lagi ni? This is the limit and fit. Okay. Limit and fit are essential in specifying the dimension for holes and also the shaft. Kebanyakan tolerance dan juga apa kata tolerance, limit, fit ni lebih kepada hole dan juga shaft. There are two standards on limit and fit as described by the American National Standard Institute (ANSI). One standard is on the traditional inch unit. Okay. The other is based on the metric unit. Maksudnya kita ada dua standard, satu inci, satu lagi unit lah, sentimeter, milimeter, semua tu and has been developed in greater detail. In this standard, letter always refer to the hole and lower case letter to the shaft. Kalau macam ni, H ni, H7 ni, tadi dah tunjuk video tadi kan, H7 dia ada tolerance tadi, H7 ni lebih kepada hole, kalau H yang kecil ni lebih kepada shaft punya turn. Okay. Ini simbol lah, simbol apa kata, kalau tengok graf ni adalah antara dimensional tolerance dan juga critical part dimension, and then this is adalah dia punya apa kata machining process yang suitable lah untuk tolerance tu. Okay, if let's say kalau kata your dimensional tolerance you adalah 0.1 and then typical part dimension adalah lebih kurang 10, maksudnya dia punya the suitable machining, the suitable apa kata manufacturing process adalah investment casting. Itu contoh-contoh. Ini simbol-simbol lah yang berkaitan. Ini semua you dah belajar dalam engineering drawing. Okay, in summary, in modern manufacturing process technology, many parts are processed using a high degree of precision and thus require measuring instrumentation with some features and characteristics. And then many devices are available for inspection, from simple gauge block to electronic gauge with high resolution. Yang tadi kita tengok kebanyakannya semua adalah yang standard, yang traditional punya gauge lah. The selection of a particular measuring instrument depends on other factors such as the type of measurement for which it will be used, the environment in which it will be used, and the accuracy of the measurement. Maksudnya measuring instrument tadi depends kepada tiga faktor yang berbeza, iaitu environment, dua faktor, environment dan juga accuracy the measurement tadi. How precise that you want to measure. And then major advance have been made in automated measurement, linking measuring devices to microprocessor and computer for accurate and process control and manufacturing operation. Okay. Reliable linking, monitoring, display, and manipulation of data are important factors, as are the significant costs involved in the implementing them. Okay. Jadi advance untuk measurement ni kita menggunakan yang automatic punya style. Okay. Ini pula dimensional tolerance and selection are important factors in manufacturing. Tolerance not only affect the accuracy and operation all type of machinery and equipment, but also can influence the product cost significantly. Ingat tolerance, limits dan juga fit tadi dia penting necessary pada untuk produk-produk yang perlukan assembly. Okay. And then the smaller ataupun the tighter range of the tolerance specified, the higher is the cost production. Makin kecil you punya tolerance tu, makin tinggi you punya cost production, and then makin tinggi manufacturing process yang you perlu buat. Okay. tolerance should be as broad as possible, but should also maintain the functional requirement of the product. Okay. Okay, any video links tadi you boleh dapatkan di sinilah. Okay. So, itu saja kita kelas hari ni. Memang sekejap je. Bab metrologi ni benda-benda yang simple, yang you pernah belajar pun daripada dulu. Okay. So that hari ni kita tak ada apa-apa aktiviti. Lagi pun kita dah week ke-14. Minggu depan adalah week ke-15. Kita belajar. Minggu depan macam berat sikit lah. Dia lebih kepada minggu depan macam apa pun kata banyak kena faham lah. Iaitu lean manufacturing. Which mean chapter minggu depan kita akan fokus kepada lean manufacturing yang mana you kena ada buat assignment. Individual assignment mengenai lean manufacturing. Okay. Itu minggu depan punya task lah. Okay. Jadi kalau tak ada apa-apa, saya ucapkan terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Teh.
Kak Yulen ada aktiviti.
Yes?
Kak Yulen ada aktiviti.
Tak ada.
Ada ni.
Kak Yulen, you just pergi untuk ni je, untuk buat apa kata, tick you punya attendance. Boleh?
Yang which welding technology is categorized as
Oh, yang tu last week-nya. Itu just untuk, saya just untuk apa kata, lebih kepada untuk, apa kita panggil blended learning je. Tak apalah, tu kalau nak jawab, you jawab, tu senang je. Kalau tak nak jawab pun tak apa.
Okay. Ya?
Doktor, next week baru start assignment, doktor.
Next week baru start assignment. But next week assignment kita lebih kepada yang lean manufacturing tu. Tak ajar lagi mana boleh nak assignment. Kang pening lawak. Okay.
Dia handwritten menaip.
Nanti saya tengok macam mana dia punya tu. Depends lah, depend pada minggu depan punya ni macam mana.
Baik, doktor.
Okay, alright.
Thank you, doktor.